Hey scientists, Caroline here. I could use a drink of water. Hey, where's the water? What's going on? Why don't I have running water? Oh, wait, I'm getting an alert on my phone. Oh no, the city found nitrate pollution in the water system. I won't be able to use my tap until tomorrow. Luckily, I have some bottled water saved for emergencies. Over 70% of people around the world today have clean running water in their homes. Clean water is one of humanity's greatest achievements, but as populations grow, it's still an ongoing challenge. Today we'll explore how water pollution impacts our health and how people are working to protect our precious, limited fresh water. Not only is running water an amazing innovation, but clean running water has been one of the most important advancements in human health in modern history. In our last lesson, we learned about water pollution and the harmful substances that contaminate water. Do you remember any of the 4 types of water pollution? Wastewater, solid pollution, chemical pollution, and thermal pollution can all harm aquatic ecosystems. But these types of pollution aren't just bad for wildlife. They can cause serious health problems for humans who drink polluted water. Human or animal waste can introduce microorganisms like bacteria into water, causing infectious diseases and digestive issues. Nitrogen from agricultural waste can prevent red blood cells from carrying oxygen throughout the body. Chemicals and heavy metals can build up and cause long-term damage to the liver and kidneys, or could even cause cancer. And small solids, like microplastics, may disrupt the normal release of hormones in the body. Healthy rivers and lakes naturally help filter pollution, but human activities can overwhelm these systems. When plants are removed and paved over, too much wastewater and runoff flow into the water too quickly. The natural water filters in an ecosystem can't keep up, and more pollution gets into the watershed. As populations grow, we use more natural land for urbanization and generate more wastewater, further contributing to the problem of polluted water. Less than 1% of Earth's water is accessible freshwater, so we must protect it from pollution. Thankfully, we have systems that help us remove pollution from freshwater before it comes out of our faucets. After humans use water to cook, clean, or flush the toilet, the dirty water goes down the drain. What do you think happens to this water? Pause the video here to record your thoughts. Dirty water has to be cleaned and treated so it can be released back into a body of water or returned to your faucet to be used again. This process is called wastewater treatment, the removal of pollutants from wastewater and sewage so that it can be used again without harming human health. Modern wastewater treatment has multiple steps to filter out different types of pollution. The first 2 steps of wastewater treatment remove solid pollution. How do you think solids might be removed from wastewater? Wastewater is passed through a series of filters and screens to remove solid pollution. Then good microbes are used to break down any smaller organic waste. Finally, the wastewater is treated with UV lights and chlorine to remove bacteria, chemical pollution, and nutrients like nitrogen. Accessible freshwater is an extremely limited resource. How does wastewater treatment help us use this limited resource more sustainably? Pause the video here to record your thoughts. By treating dirty water, we can clean it and recycle it over and over again. This reduces waste because we aren't using water one time only. It also helps protect the environment by removing pollution before any water is released back into aquatic ecosystems. If you're interested in learning more about how wastewater is treated, check out the extension in your lesson activities. Wastewater treatment is an effective way to clean water from sewers, pipes, and drains. But not all water pollution comes from the drain. Sometimes pollutants flow directly into bodies of water. The Clean Water Act of 1972 not only set national standards for how to properly clean wastewater, but it also made it unlawful to purposely release pollution into water without a permit, like dumping chemicals into a lake. By reducing the direct release of pollution into water and setting rigorous standards for cleaning the water that goes down the drain, the Clean Water Act has led to safer drinking water and improved health outcomes for humans. Problem solved, right? Well, not exactly. Humans can also consume water pollution without turning on the faucet at all. Welcome to the Atlantic Ocean. This salt water isn't used for drinking, so it won't come out of your faucet. But the Atlantic Ocean is a major provider of seafood for the United States. Tuna, salmon, swordfish, scallops, shrimp, and crabs are all pulled from this ocean and transported to grocery stores around the country. But here's the problem. When pollution, like pharmaceuticals, microplastics, or heavy metals like mercury, enter the ocean, they don't get filtered out. Salt water doesn't go through wastewater treatment like drinking water does. Even though we don't drink ocean water, these pollutants can still reach our bodies through the seafood we eat. Let's take a look at mercury pollution, which can harm the nervous system if too much is ingested over a long enough period of time. When small amounts of mercury enter the ocean water, the concentrations are usually too low to harm human health. But we're not drinking this water. We're eating the fish that swim around in it. Tiny organisms like phytoplankton and aquatic insects absorb mercury from the water. The amount is small enough that it doesn't kill them, but the mercury bioaccumulates, meaning it gets stored in their tissues. These tiny organisms are at the bottom of the food chain. Take a look at this simplified ocean food pyramid. Remember, only 10% of the energy at one level moves up to the next consumer. So higher level consumers like tuna and swordfish need to eat a lot of food to get the energy needed to survive. How does this impact the amount of mercury ingested by and then stored in the tissues of top consumers like tuna and swordfish? Pause the video here to record your prediction. Each insect only has a little bit of mercury, but small fish eat lots of insects. With each insect eaten, that mercury builds up in the tissues of that small fish. Then each tuna eats lots of small fish, and all of that mercury in each small fish builds up in the tuna. This is called biomagnification. As you go up the food chain, pollutant levels increase in each predator. By the time humans eat a fish like tuna or swordfish, mercury levels in its body may be much higher than they were in the water, or even in the prey it ate. That's why it's so important to prevent water pollution, especially from substances that bioaccumulate, like mercury, pharmaceuticals, and microplastics. If we can take actions to prevent these substances from entering watersheds or the ocean, we can better protect ourselves from the pollutants in the food and water we consume. So what can you do? Reduce your plastic use as much as possible. Never flush medicines or chemicals down the drain. And get involved in your local community, educating others about the dangers of pollution and the need to control point source pollution whenever we can. Through personal actions and innovative water treatment facilities, we can make sure that people are protected from the health impacts of water pollution. As we went through the lesson today, we learned how water pollution can cause serious harm to human health. Luckily, with legislation like the Clean Water Act, we've made incredible progress, setting strict regulations to clean wastewater and to prevent people from dumping pollution into bodies of water. This leads to cleaner drinking water and less pollution getting into the seafood we eat. With new innovations and everyday actions, we can continue to protect this essential resource for the future. Until next time, remember, every drop of water is a part of a bigger system. By understanding how water pollution happens and the damage it causes, we can develop sustainable solutions to tackle this problem. Keep learning and asking questions, and I'll see you next time. Hey, hey.